This is Algebra 2 with trig. This is the review for 7.1 to 7.4. This is page number 4. Here we're expected to use calculators. Here we have an equation. It models a situation. What was the value of the car in 1984? So we grab our calculator. And we go to y equals. And we can type in our 11,000 to the 1.069 to the x power. The value of the Hudson Hornet, convertible since 1984. So in 1984, since this is since then, we are expecting that the value would have 0. What is the value of the car in 1984? If this is the equation since 1984, then this is 0. Y equals 11,000, 1.069 to the 0 power. So that's going to be 11,000. We can see that in our table. When x is 0, we get 11,000. What is our growth factor? The growth factor is 1.069. It's the 1 plus the percentage of growth. The percentage of growth that we have, we take our 0.069 and we move the decimal spot over 2, so 6.9. Here we have an equation, and it models the membership in after-school athletics each year since 2000. The 54 represents the membership in after-school athletics. You could say the starting point is often what the A is. The number of people playing sports in 2000. Seems a little bit low, but okay. What is the decay factor? 0.97. And what is the decay rate? Well, the decay rate, 1 minus something is going to equal 0.97. So when you subtract the 1, you get to 0.03. So we're decreasing at a 0.03 rate. So what is the decay rate? That would be 3%. You're going to deposit $250 into your account when you're a sophomore to save money for your senior trip. The account pays 2.92% interest. Determine the balance of the account after 2 years. Semi-annually, so that's twice. So if we're going to have compound interest, we know that we are going to use the equation 1 plus 1 over n to the nt. So your account is going to start out with $250 1 plus your interest rate, which is 0.0292. Semi-annually should mean that you're doing that 2 times during the year. So your N is 2, and you're going to do that for 2 years. So what we'll do is come over to your 0.0292 and divide that by your N value. So we're now going to have 250, 1.0146 to the 4th power. So we can raise that to the 4th power, which is a very small number. Well, actually, I didn't do the 1. That didn't work. So we have 1 plus the 0.0146, and we get to raise that to the 4th power. That looks better. I knew that this was a growth factor, so I knew that my value had to be greater than 1. $0.597 if you want to round that up. But I would suggest to use the real value here. Say 250 times your answer. So your account is going to have $264 in it and 92 cents. Now let's see if our bank, if it would compound it monthly. That means you're still starting out with your 250. You're still getting the 0.0292 interest rate, but now you're going to get money every month, not just twice a year. So we take our 0.0292 and we divide that by 12. So that gives us a small value there. And 12 times 2 is 24. So we're going to take our, add 1 to that number. So now we have the 1.0024. Raise that to the 24th. Times that by 250. Not dramatically different, that's for sure. Okay, but the more times you compound it, the better off it'll be. So you do have a higher account result than you did if you compound it semi-annually compared to monthly. In 1990, the population of Canton, Ohio was 264,200. During the next 10 years, the population increased by 3.2% each year. So we're going to write a model given the population. So a model is y equals, the starting point was 264,200. It's a growth factor of, let's see, we would typically say plus our R value. What we're doing here, by the way, is y, or, yeah, equals P 1 plus R to the T. That's the formula we're using. So our rate is 0.032. You've got to move the decimal spot to the left. And we're writing a model after T years, so we're just going to use a T there. So that is our model. What's the population in 2008? Well, in 2008, we've been doing this calculation since 1990. So you could see that we'd have 18 years later. So we're going to take our 264,200 to the 1.032 to the 18th power. And we times that by 264,200, and we have 465,000. 465,765. That would be a flood of new people. Okay? If it scares you to have a decimal version, you could round that. But this is people. All right, we're going to graph this on our calculator and estimate the year the population was this value. Well, we go to y equals. We have our equation of 264,200 at our 1.032 raised to the x. Now we want to get close to 340,000. We can use our table, and we see that 340,000 was somewhere close to 8. But let's see if we can get any bit better than just saying 8 or 8 and a little bit. Let's get the graph to do it. But for me to be able to see the graph, we need to have the window open the right way. So we know that we have to get to a height of at least 340,000. So let's just call that 4,000. So we need to go to our y maximum and put in 400,000. There it is. It's not growing very quickly, but that's not quite straight. All right, that's not quite straight. It is curving. Okay, we're going to look to see when are we going to be 340,000. So we're looking to see where those 2 points match. So we do second trace, find the intersection, and they ask you for the first curve, enter. Is that your second equation? Enter. Guess. You can just hit enter in this case. And we get an answer of 8.0079. Okay, so our table was pretty much as accurate as we can get there, but this would be the even more accurate if we were to go that many decimal spots. Discuss why you think anyone would move to Ohio. Just kidding. Well, Canton, Ohio, that's the Hall of Fame of the football, so that would be fun to go see. Alright, I'll start this one on the next video.